Good morning to one and all. Today I am going to tell you about system interface and my name is Shenmala Mumtaz. What is a file? File is a collection of similar data. The file system interface. In file system interface provides the mechanism to access data and programs of the operating system and the user of the computer. The file system consists of two distinct parts. One is the collection of files and second is the directory structure. In collection of files is used for storing the related data. In directory structure, it is used to organize and provide the information about the files. File concept. A file is a collection of related information that is recorded on secondary storage. For a user perspective, a file is the smallest allotment of logical secondary storage. As we can see in the diagram, a file, first of all, file is present in the disk. From disk to the OS, OS to the files, and files to the file system. Here we can, in file system, we can save several files, has the size of the files, attributes, location, all this comes in the file system. Next, there are four common terms used in the files. They are the field, record, file, database. So coming to what is a field? Field is the small basic element of data. That is, the individual field consists of a single value. For example, if you take the employee list, here the employee name is a field and the date also is a field. Here it is characterized by its length and data type. Then coming to record. Record is nothing but a collection of related fields that can be treated as a unit by some application program. For example, when coming to the employee record, all the field names such as the name of the employee, security number, job classifications, date of hire, and so all these fields is a collection of all these fields is known as a record. Then coming to the file. What is a file? File is a collection of similar records. The file is treated as a single entity by the user and application. Database. Data is a collection of related data. Now coming to the attributes of files. In files we have different attributes like the name, identifier, type, location, size, protection, time, date, and user identification. And coming to name, the file name is only the information kept in human readable form. The identifier is nothing but the unique ID. The unique tags such as usually numbers, IDs identifies the file within the file system. It is non-human readable name for the file. Next, the type. The information that is needed for the system that supports different types. Here we have different types. That is the data may be in some int form or some in cat form. Location. The location is nothing but the address of the file. Here the information is pointed to a device and the location of the file on the device. Here the size is nothing but the size of the files. The file size can be in bytes, words, or in blocks. The current size of the file and the possible maximum allotted size are included in size. And next, the protection. Here the access controls determines who can read, write, or execute. So here some access permissions are given for the protection of files, because nobody cannot, somebody wants to change the bytes, he should have the permission to change the data. Reading means he can allow them to read. And next, coming to the time, date, and user identification. This information is used to create or modify the last use. This data can be useful for protection and security. The file operations. So the file operations are creating a file, reading a file, writing a file, reposition within a file, deleting a file, truncating a file. So when coming to creating a file, there are two steps for creating a file. First of all, there should be a space to create the file. First space in the file system must be found. Second, a new entry for the file must be made in the directory. As we all know that in Notepad or in MS Office, first we will go for the options, file. Here we will, if you want to create a new file, we will go for the new file option. If you want to open the previous file, we will go for the open. Here again we have to save the file. Here the directory entry records the name of the file and the location in the file system and possible other information. So here the location means if you want to save this file, first we will give the name, create a file, and we will save, and we will give some path, or to if you want to save in the D drive or in the desktop or in any document, we will give the path. Next, writing a file. To write a file, we make a system specify both the name of the file and the information to be written to the file. So first, if you want, first we should open the file. In that we should write the name. The name, by specifying the name, we will open the file, and if you want to write any information, we will write in that file. Giving the name of the file, the system searches the directory to find the location of the file. Here the system must keep a write pointer to the location in the file where the next write is to take place. If for example, if you are writing something on the notepad or in MS Office, the write pointer will be there at the location where we will write some data, and the pointer will be at the last point where we have written the data. If you want to, again the pointer does not go to the starting point, it will be there where we have stopped. So here the write pointer must be updated whenever a write occurs. Next, reading a file. To read from a file, we use a system call that specifies the name of the file where the next block of the file should be put. Here in the directory is searched for the associated directory entry, and the system needs to keep a read pointer to the location in the file where the next read is to be take place. Once the read has taken place, the reader pointer is updated. Here both the reader and writer pointer should be updated. Repositioning within a file. The directory is searched for approximate entry, and the current file position is set to given value. Reposition within a file does not need to invoke any actual input-output operations. The file operation is also known as file seek. Here we are just changing the location of the file. For example, if you want to change the file from one location to, we are changing the position of the file here. Deleting a file. So as the name delete means, if we no longer need this directory or the file, we will delete simply by going to the option delete. The delete file, we search the directory for the file name. Having found the associated directory entry, we release all the file space. So as the file is deleted, memory space will be allotted, and it can be reused for other files. Truncating a file. Truncating means again erasing the content of the file. The user may want to erase the content of the file but keep its attributes. Rather than forcing the user to delete the file and then recreate, this function allows all the attributes to remain unchanged except for file length, but lets the file be reset to length 0 and its file space released. Here we have different types of files. But the file types are executable, object, source code, batch, text, word processor, library, print, archive, and multimedia. So the extension will be for executable .exe or .com or .bin. For the object, we will say extension form is .ob. So in executable, it is used to read the run machine language. For object, it is used for the machine compilation. And source code. In Java program or C program, we will save the programs as some program.c or program.java. Source code in various language. Here in batch system, we will use the BAT or SH. It is a command line interpreter. Text. In MS Office, we will use this text or document for textual document. And for the word processor, we will use WP or TXT. And coming to library, we will use this library or ASOL, MPEG or MOV or ARM. These are the routines for the programmers. When coming to print view, we will use the archive or zip. These are ASCII or binary files for the printing of or for viewing. Archive. Here in archive, we will use as archive or zip. They are related files grouped into one file. sometimes compressed for archiving or storage. In multiplayer we use MPEG, or we have to display the images. The name here, the name is split into two parts. One is the name and the extension. So we will give the name of the program, and in second part it comes the extension. What it is, a text or document, or it's a some archive or different type or an object, or the extension form is given to the file name. Access method. Here the access means once the file is created, how we should access is. When a file is used, the information must be accessed and it is read into computer memory. The information in the file can be accessed in several ways. One is sequential access, direct access, or indexed access. Sequential. It is the simplest access method. Here the files are accessed one after the other. A read operation, for example, if you want to read, the read operation specifies certain portion of the file and it automatically scrolls on one by one. This is the sequential access. Here in sequential access, this mode is accessed by the editors and the compilers. Direct access. So here in direct access, a file is made of fixed length and it allows the programmers to read and write the record not in a particular order. The order is not in particular. The direct access method is based on the disk mode, since disk allows random access to any file mode. For direct access, the file is viewed as a numbered sequence of blocks or records. Here there is no restriction for on the order of reading or writing for direct access. If you want to read n, where n is, we will read n, and where n is the block number. Next one is the indexed access. This is other method of accessing a file. Here the index is given, the index, the top of the accessing, sequential access. This method constructs an index for the file. If you want, for example, if you want to search anything, we will go for the index. Here, for example, if you take a book, here we will has the index page, which the page number and anything will be there, which page we want to go. Here the pointer goes to the certain block where we want to access. To find a record in the file, we first search the index and then helps the pointer to access it, same as our notebook or test book. Next, coming to the directory. Here in directory structure, what is a directory? A directory is an object that contains the name of file system. Objects. File system allows the user to organize files and other file system objects through the use of directories. We have different types of directories. One is single level directory, two level directory, tree structured directory, acyclic graph directory, general graph directory. When coming to single level directory, it is the simplest level in the single directory. Here all the files are contained in the same directory, which use is very easy and easy to support and understand. In single level directory has significant limitations. When the number of files increases or when the system has more than one user. Since all files are in the same directory, they must have unique name, so that the same names should not be used. Because if the same name is used, we will get confused. So the different names should be given to different files here in the single level directory. Next, coming to this is the diagram of a single level directory. See, here we have the directory, the top one, the cat view, this all comes to the directory, and down below the directory is the files. So which file we want to access? Since it is a single level directory, the name should not be same. They should be unique name. Different name should be given. And next, coming to the two level directory. In two level directory, each user has UFD. Here UFD is a user file directory. So each user has its own user file directory. Each user file directory has a similar structure, but lists only the files of a single user. When your job starts, the system's master file directory is searched. So once it started, the master file directory is also present in 2-level directory. Here master level directory is the indexed by the username, and each entry points to the user file directory. When a user refers to a particular file, only then he has to search for the user file directory. Different users may have files with same name as long as all the file names within each user file directory are unique. To create a file for user, the operating system searches only that user file directory to ascertain whether another file of that name exists. To delete a file, the operating system confines its searches to the local user file directory. It cannot accidentally delete another user file that has the same name. So in secondary level directory, we have a master file directory and a user file directory and the files. So in master file directory, there will be so many users, but in user file directory we may have the same file name directory. Here if the same name exists, but if you want to access or anything, will give the master file directory and the user file directory and then the file. So by giving this path, if same name also exists, there is no chance of mislapping or going to for the another as the path is given. If you want to delete a test from the user 1, then the test from user 3 will not be deleted. It will search for the path user 1, user file directory and the file name. Now coming to the tree structure directory. So a tree structure is more powerful and flexible when to organize the files and directories. Here in tree structure there is a master directory which has under it a number of user directories. Each of the user directory have subdirectories and files. This is at any level the directory may consist of entries for subdirectories. So this is the structure of the tree structure. Here we have the root, directories, paths and number of subdirectories. So the path is very important. From root directory to we can search the path. And you can easily understand here in tree directory. Next coming to the acyclic graph directory. A acyclic graph directory allows the directory to share the subdirectories and files. Here we can share the directories and the files. The same file or subdirectory may be written in 2 different directories. A shared file is not same as 2 copies of files. With 2 copies, each programmer can view the copy rather than the original. But if one programmer changes the file, the change will not appear in the other copy. The shared files and subdirectories can be implemented in several ways. So this is the structure of the acyclic graphic. And now coming to the general directory. We can add links to the existing tree directory. That tree structure is destroyed, resulting in a simple graph structure. So this is the structure of the acyclic tree structure. Thank you one and all for giving us.